All right. Page 3, page 4. Page 4. We've got degrees that we're obviously going to convert to radians. So now we've switched this. We want to get rid of the degrees and then incorporate pi into the answer. So we just need to figure out, I mean, really, this is kind of a piece of cake. Divided by 180. And that's 5 2/3. So what is that? 5 2/3. That sounds like 17/3. Yep. All right. So that means that that's right there. All right. Pi over 180. Okay, we can do that and that. 3, well, obviously it's going to stay negative. 3 will go into these guys. It'll go into there 31 times, and then 3 will go into 18 6 times. So there's our answer there. All right, keep going here. Pi over 180. Cross out the zeros. We got 31 pi over 18. That's pretty simple. Okay, 31's prime, so no worries there. 330, actually, you could probably do that mentally. That's 30 degrees off of the, it's 30 degrees off this, so that means that's 11 pi over 6. So if you had the unit circle kind of immediately in mind, that's kind of, it's a nice little conversion quickly. Okay. All right, what's this guy? All right, these can be, I think they're kind of fun. What you do is you want to think of, you can see how it has spun around a couple times. There's 1 and then 2. So that is 2 pi plus 2 pi. We got 4 pi right now. And then we'll notice that we got all the way, there's 4 pi and then this guy right here. Now, if this reference angle, this distance right here is 11 pi over 6, this distance from here to here is actually 6 pi over 6. So what we've got here is this distance from here to here is actually 5 pi over 6, because this and this together will form the 180. Okay, so this pi over 6 and 5 pi over 6, they're what's called a linear pair. They form a line when you put them together. So now what I've got is I've got 5 pi over 6 plus 4 pi. Now I need this to be a common denominator of 6. So 6, how many times will 6 go into, like, if you have 4 pi, how many 6 is that? And that would be 24 of them. 12 pi over 6 is 2 pi. So 4 pi is 24 pi over 6. So add those guys together and you're going to get your 29 pi over 6 right there. Okay, now this is kind of the same thing, but now we're at a different location. So we go 1. Now notice we're going negative, by the way. Okay, so that crosses out that guy. We're going negative. Okay, so that's a negative 2 pi. And then we're going to add another pi over 6. So this is actually, add those guys together. This is negative 12 pi plus a negative pi over 6. They're both over 6, so there's our negative 13 pi over 6. Okay. All right, let's see if this guy is, next one is quick. Yeah, might as well keep this the same. All right. Okay, this is kind of, well, no, not too bad here. Okay. The reference angle means then that I need, a reference angle is always in between 0 and pi over 2, okay, or 0 and 90 degrees, okay. It's got to be a positive and it has to be a small angle. You really just want to find that distance to the x-axis, okay. So this turned this way, negative 7 pi over 9, so this distance has to be a negative 2 pi over 9, because together they're going to be negative 9 pi over 9, okay? Now, because it's negative, though, we don't care for reference angles, okay? We don't want it, because the sine and the cosine for a reference angle is the same everywhere, okay? It's just whether or not it's positive or negative. So a reference angle is always going to be positive, so just take that negativity off right there. Okay, so this is 19 pi over 6. And what we're going to do is we're going to get rid of that spin right there. So we're going to subtract 12 pi over 6. And then we're going to subtract another 6 pi over 6 so that we can get rid of all of that. It looks like this is actually what's left is 19 pi over 6 minus 18 pi over 6. That's just pi over 6. All right, so there's only a pi over 6 left right there. Okay, all right.